think I might be zoomed in from last hour. I hear you, and I am attempting to address your concerns.
Okay, thank you. Bless you.
Did anybody draw like they have to go up against the 1 or 2 seed? Or even like 3 or 4?
I think if I looked at the bracket, I could. I think Tyler plays a seeded team.
Okay. But it wasn't like half your team or anything. How big is the bracket? How many?
There's 19 teams.
Okay.
And then there's like 25 ones.
Yeah, because you can do extra, yeah. Alright, so there's 4 situations where you cannot take the derivative at a point. Before I just like tell you that one, let's see if you can pull this up. What could possibly happen at a point on a graph that you'd be like, yeah, I can't take the derivative there? Asymptote, that's going to fall under a certain category, but yes. A jump, that's the same category as what? So what? Discontinuity. So discontinuity could be a jump, could be removal, or it could be a vertical asymptote. So if there's a discontinuity there, you cannot take the derivative. Oh yeah, okay. What else? The rest of them are pretty hard, I think, but let's see if we can come up with anything. Not really. Well, a little, maybe. Just gonna say like math terms and think they apply. Multiplication. Conjugates. Fraction. Yeah. What do you mean a point? Yeah, so like a corner. What you're saying? Point's a tough word because like there's points on a graph, but you mean a point like yeah, like okay. So that I'm gonna call it corners and cusps. Well, a corner is like that. A cusp is like that. And then this is like a word I made up, but it'd be like a cusp corner. So it's like one of each. It's not a wave, it's a cusp order. My word's better. So if I ask you to take the derivative at this spot, not necessarily even positive, negative, it could be like that. Like those are both negative, right? But the derivative is asking you for the slope. And which one would you choose? Because there's like 2 different ones, right there. So if I ask you for the slope at that spot, would I be like, well, use that one or that one? So it's because, you know how in limits, the limit had to be the same for both sides? Same idea. If you're going to take the derivative.
The slope approaching from the right.
I could. But if I just ask you for the derivative at that point, you can't do it because it doesn't match. So the slope or the derivative is not the same from each side. And number 3 is kind of the same thing, but most people understand it better if I explain it differently. piecewise where slope doesn't match, and I'm going to go through a couple of these on con in a minute. This essentially creates a cusp or a corner or a wave or a cusp corner or whatever you want to call it. But just to like write one down here, say I gave you f of x equals 2x when x is less than 0, and x squared when x is greater than or equal to 0. So first of all, if it's a discontinuity, we can't do it. So that's the first thing we check. Is this function continuous when x equals 0? And it is, because if I plug 0 into the left hand or the top one, what do I get? 0. If I plug 0 into the bottom one, I get 0. So it is continuous. If it's continuous, it's like one check mark, but we got to keep going to see if it's also differentiable. So what's the derivative from this side? 2. And then what's the derivative from this side? 2x, and x is 0, right? So like the slope here is 2, the slope here is 2x, which is 2 times 0, which is 0. So since those slopes don't match, you get a situation where you got a slope of 2 and then a slope of 0. And if I say what's the slope at that point, you don't know which one to take. So it just becomes you can't take the derivative at that spot. Does that make sense? And then the fourth one, I don't know if anyone will ever come up with. This is tough. Let me try to hint you there, though. Like, so if the slope is undefined, that would mean the derivative is undefined. Like we can't. Derivative means slope. So if the slope's undefined, meaning you're trying to divide by 0, derivative is also then trying to divide by 0, and you're undefined. So what situation would result in a slope that's undefined? Graphically, what would that look like? So if the graph goes vertical at any point, which is pretty rare, but there are graphs that go like kind of like that, and you get this instant right here where it's actually vertical. So if you have a vertical, not a vertical asymptote, but a vertical tangent line, like your surfboard is actually vertical. Then your slope is undefined, which means the derivative is undefined. So we can't take it. I like that. Your surfboard crashed.
Wait, wouldn't that mean the entire thing's not functioning?
So you can get these like, it can. But you can get these spots where it like, kind of like just for that tiny instant is vertical, but it's not actually 2 points there. It's just like so close that it slides up versus.
So it is a function.
So technically that would be a function and it could have a vertical tangent.
So like,
It's like, you would never do that algebraically.
Hey, but how would you know? Stuff on that.
They would tell you like, so the AP test would say like, here's y is left of x, there's a horizontal tangent line here, vertical tangent line here, blah blah blah. And try to like hide it among other information and then be like, okay, tell me where. So I just want to do a couple on con. It's most of the piecewise stuff that I was worried you guys were going to struggle a little bit with. I don't think it's that bad, I just hadn't really taught it, so I'll keep the video running too. So differentiable at a point algebraic. So if I were doing this one, so they're asking me, is it continuous and is it differentiable? So first of all, for continuous, we're plugging in the x values to those and we see if we get the same thing. See if those rows. So if I plug in 1 in here, what do I get? Is this big enough or should I like
I need it bigger.
Zero.
Just open your eyes. Oh, that's better.
So if I plug 1 into this, I get 0. If I plug 1 into this one, I get 0. So let's say like f of 1. Well, so it's continuous. Agreed? Differentiable is a little bit more work on this one especially. So what's the derivative here? It's 1. So it's like 1x minus 1 there. So remember the derivative of a constant times x is the constant? Like what's the slope of y equals x? Is 1, right? So your slope here is 1. This one takes a little more work. There's a rule, there's like a shortcut where we have like a chunk like that squared, but we haven't learned it yet. So you'll have to actually square that. Please don't tell me x squared minus 1 or plus 1, either of those. You gotta square the first term, then you'd have x times negative 1, but you'd have it twice. So it's x squared minus 2x, and then negative 1 squared is 1. Take the derivative as 2x minus 2, and plug in 1 there, what do we get? We get 0. So the slope up here was 1, the slope down here was 0. It was continuous, but it's not differential. You know what I'm saying? I don't really care what the letter is. I want you to understand what I'm talking about. Yeah.
Usually just put the power down in front of the parentheses and then distribute it.
So that's the chain rule. The difference, the only thing you got to be careful of there. So the rule for chain rule, we're getting this like next week. You would bring it down, you'd leave it just like you said, but then you got to multiply by the derivative of the inside. It's like an extra piece that comes out. And in this case, the derivative of the inside is 1, so you'd be upset. But don't let that trick you into thinking it works all the time. You know? All right, let me go through. I don't care. Here, I'm gonna put B just to piss you off.
No.
Move on.
Like that.
Do that one.
I really prefer.
I don't have to get 100%. I don't need to read it. If it's not continuous, do you even have to check if it's differentiable or not?
Oh wait,
No.
no.
If it's not continuous, it's automatically not differentiable. So if I plug 2 in here, 2 times 4 is 8 minus 2. So this will give me 6, right? And then 8 times 2 is 16 minus 22. This will give me negative 6. So is this continuous? It is not. So is it differentiable? It cannot be. So it's got to be neither. Does that make you feel better if I get it right? Let's look at a graphical one for a second. I haven't even opened this yet, but let's see what we get here. Okay, so it's not differentiable there. Why? It's kind of 2 reasons. It's a corner. Yeah, so negative 2 is 1. They're trying to trick us here by making it like smooth horizontal, but that's fine. It's just vertical that's a problem. So Devin, this is what you're saying. Like, how do we know? So it told me up here there's a vertical tangent at x equals 4. Kind of like a dead giveaway. Like if I were them, I'd put other information there too, just to like mask it. So 4 is an issue, and then isn't 2 also an issue? So negative 3, why? Is it discontinuity? 1, why? It's discontinuity, and 3, cos corner, whatever you want to call it. Oh, I'm sorry, did I go too fast? That 3 was like a corner. 1 says a vertical tangent, and again, it almost like tells you right there. 1 and 5. I don't think that's like a corner up there. It's like annoyingly. So no, the option it gives me is -2, and that's a pretty smooth. Like I was thinking -3, if anything. Yeah.
Yes.
So we crushed it.
That means you don't have to do that one.
That means I'm done.